Okay, continuing with number 17, I had plotted my start point, realized from the pattern, from the first letter of the pattern, that the start point 0, 4 was at the middle level. I installed the middle shelf, amped up 2 units to get the upper shelf, and amped down 2 units to get the downward shelf. Okay, so now plotting the rest of the points by looking at the pattern. And you won't have to use the pattern for long because right away you're going to see, what the shape of the graph is. So the next point that I'm going to plot says to do a point at the downward shelf. So make sure that you're moving whatever the amp is, which is pi over 8, and plot the point at the downward shelf. Then move over pi over 8 again. Pattern now says go to the middle shelf. So now you're going to plot a point there. Move over pi over 8 again. The pattern says go to the upper shelf. I'm moving through these letters that are in the pattern, doing whatever they say. Okay, so you're going to go like this. At that point, you don't need the pattern anymore. You can see that you're going through 3 points as you go up. You're going to go through 3 points as you go down. So slide over, start to come down. Slide over, all the way down. Once you've gone through 3 points on your way down, it's time to start going up. And you're going to travel through 3 points again on your way up. So it's slide over pi over 4, start to go up. Pi over 8. Slide over pi over 8, all the way up. And then you can see the whole graph emerging. And then if you want to get some points on this side, this one was on its way up. You had gone through 2 points. So you need that third point to go all the way up. And then you'd have to start coming down. So come down, slide over pi over 8, all the way down, and so forth. And then you could start on your way up again. Okay, that is number 17, all the way done. Okay, moving to number 18. In problem number 18, your amp is 7/3. Your B value is negative 2 pi over 3. So we're going to begin by doing the period. The period's 2 pi divided by the B value. That's the formula. So it's 2 pi divided by 2 pi over 3. This entire value here, the 2, the pi, the 3, all of that is considered the B value. By the way, given in the theorem pages where it was a discussion of the odd and even functions that were introduced in section 6.2, and then I reiterated them again for you in section 6.4. Here they are again on the very first page of the theorem pages. You have some functions that are considered even, so if they do try to throw you a negative value, an even function swallows up the negative so that it is completely gone. Whereas an odd function, you cannot get rid of that negative. This is an algebraic property. If it's an odd function, sine, cosine, cosecant, tangent, or cotangent, these 4 are odd, then the negative floats out to the front and ends up flipping the graph over. Whereas if it's cosine or secant, you can just erase the negative. So let's look at what we have here. This is not cosine, nor is it secant, so that negative doesn't go away. It comes right out here and flips it over. You might want to rewrite that just so you don't forget about the fact that you are going to flip the pattern. Okay, that doesn't change the calculations that I'm doing because I didn't use the negative anyway. Okay, so anyway, I was on my way to finish this period, 2 pi over the B value. I've already gotten that negative out of the way where the B is. I want my B value to be positive. And I was trying to do this. It's a complex fraction, as you have seen occur many times in this section. So to simplify it, you float that fraction up to the top and flip it over. So 3 over 2 pi. Multiply by the reciprocal. That's the same thing as dividing by a fraction. So that's not there anymore. It's up at the top. This entire 2 pi cancels with that entire 2 pi, leaving you with 3. So that's your period right there. Okay, then We did the jump after we got the period. We already floated that negative out to the front. So the formula for jump is period divided into 4 parts. So my period was 3, and I'm dividing it into 4 parts, so that's my jump. So I'm probably going to redesign this x-axis as well because these numbers are not convenient for what we're doing. I think you can change those on MyMathLab. You'll have to mess around with that and see if that's possible. But instead of using these numbers, I'm going to put my own numbers because I want to label my x-axis like you're going to be doing on the test with numbers that correspond to the jump. Okay, so like this first one will be 3/4. The next one would be 6/4. You're counting in increments of 3 on the top. The next one, see now they're going to jam right into each other, so I better not label every single one. So hang with me here as I label these. This is 3/4, 6/4, 9/4. Then this one would be 3 more. It would be 12/4. Next one would be 15/4. Next one would be 18/4. Next one would be 21/4. Every little grid mark is an extra 3 on the top. This first one was 3/4. Let me see if I can get a sharper pencil. Okay, so 3, 6, 9, 12. Not using these numbers anymore. 3, 6, 9, 12, 15. That would have been 18. 3 more is 21, and the same number is over here. So this would be negative 3/4, 6, 9, 9/4. Then that would be 12 at another 3. This would be negative 15, and so on. Okay, now I'm not going to force numbers on you in the when you take the test. You'll be able to put your own numbers. Just MyMathLab likes to make it harder. Okay, so now we're going to do our start point. Start point is when you zero out, as I've said in every problem, we're going to zero out that argument. So put a 0, and you can be looking at this one where you already took the negative out. Put the 0 right in there. That zeroes out this whole thing so that when you go to look for this y value, you're just using this equation right here, but with the 0 in there. So it'll be negative 7/3 times sine of, imagine putting a 0 in there as you've stated that you're going to do here. 0 times 2 pi over 3 is 0. That gives you a nice, easy value to plug in your calculator. Okay, so now you're going to plug in your calculator. You can plug it in like this. Negative 7 times sine of 0, then divided by 3. That's the easiest way to plug it in. Unless you want to put a fraction in, then go for it. Okay, so this is, when you plug this in, this is going to be equal to 0. Your start point is 0, 0. Okay, so now go put your start point at the origin, and then you can use the pattern. The pattern for sine is mum-d in its original form. However, because of this negative, we are going to flip the whole graph over. In other words, when we should have been going up, we're going to be going down. When we should have been going down, we're going to be going up. That'll make the whole graph flip over. Put those m's where they belong. Don't forget to just concentrate on your new pattern. So now to get the rest of the points, we're going to be looking at this new pattern. And we're going to go sliding over 3/4, just like the jump says that we should. And the next thing that we're going to do is go to the downward shelf. Now you better put the shelves in ahead of time because that just makes the whole rest of the graphing process easier. When we went to do the start point, that always has to do with the first letter. So that first point that we plotted, that is the middle shelf. So says the first letter of the pattern. If you want the upper shelf, then just pay attention to the amp. The amp is 7/3, which is 2 1/3. So that's going to be, I'm going to approximate here. 7 divided by 3, 3 goes in there twice, it's 2 1/3. I'm going to up 1 up to approximately right there. That'll be our upper shelf. And then you can go down 2 1/3. Okay, so to get the other points now I want to do this next letter in the pattern. Just remember to slide over whatever your jump is and then do what the pattern says. We're going to go down, middle, up. Slide over 3. We're going to go down. Typically we'd be going up from there, but this is flipped over and this is what makes it flip over. Now slide over 3/4. You're all the way at the bottom, so you can't go any lower. You have to start going up. You really don't even need to look at the pattern. Just slide over 3/4 back to the middle. Slide over 3/4 all the way to the top. Now you can't go any further because you've already gone all the way to the top, so you have to start coming down. There's always 3 points coming down, 3 points coming up. So if you're right here, slide over 3/4 and go to the middle. Slide over 3/4 all the way down. Slide over 3/4. Now look, you're already down at the bottom. Start coming up. Slide over 3/4 back to the middle. Slide over 3/4 all the way to the top. And then you can get more of the graph over here by doing the same thing. Okay, and problem number 19. Now all of a sudden in 19 and 20, you're being asked the same type of question. What is the equation rather than you giving the graph? So you're going backwards here. So if you want to know what the equation is, they're telling you basically, they use this little omega symbol as their B value. That's just the symbol that my math lab happens to use. But you're really looking for the B value so that you can write the form of the equation. So a graph that doesn't go through 0, 0, but starts up here in the air, that is the cosine graph. So we're going to go period. Start off with that period formula, which is 2 pi over 4. Now verbally I can describe the period to you as the distance between 2 maximum points, or you could look at the distance between 2 minimum points. So here's a max, here's a max. Count that out with your finger. This one's at 0. And then let's look at these grid marks. This is 2, 4, 6, 8, 10. Okay, so wait, now these actually count for 1. There's actually 14 notches here. So the distance from here to here, if these each count for 1, that's 11, 12. Now wait, let's see, that looks like 10. So this would be, or maybe 9. This is 10, 11, 12, 13, 14. So that's 9. 10, 11, 12, 13, 14. On my math lab, you can blow them up. So notice that the distance from here to here, 9 spaces. Or if you go from low point to low point, you'll also get 9 spaces. That 9 spaces is called your period, from max to max or from min to min. Now bring that information over here, right in the formula for period. Well, let me rewrite this again because I put a 4 there. That should say period is 2 pi divided by b. That's the formula for period. But you already know what the period is because you just got it off the graph. So put 9 here, then copy the right-hand side. Now solve for b. When you are solving this kind of problem, shortest way to do it is interchange these two. You can't solve for a variable that's down in the denominator. And you can get that variable up here by just doing a simple switch. This is a form of cross multiplication. Put the b in place of the 9 and the 9 in place of the b. And in making that swap, you have done a one-way cross multiplication and you've also solved for b, which is what you need to write the equation. So you're going to go write your equation now. You're using this form right here. This is not a flipped over graph because it goes up right away and then starts coming down. And so it's going to be the amp. Look how tall these waves are. When you go from here to here, you have a distance of 1, 2, 3. And if you go from here down to the bottom, you have a distance of 1, 2, 3. So how tall the waves are, that is your amp. So from here to here, that